Okay, so with this problem, it's a real life example of a pendulum. If you think that's that thing that rocks back and forth, it kind of stands up on a stand like this, and then the ball's like that, and it goes this way and this way. And then you pull it, and then each turn it gets closer and closer together. So that's what it says. With each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance of the pendulum, or what is the total distance the pendulum swings? So, if you see this, this is kind of like a visual aspect. This is the first, that's the second, that's the third, and that's the fourth. So if you see each time it moves, it goes that direction. So the way we're going to do this is we're going to look at it with the infinite geometric series because it is 80%, guys. 80% is like 80 cents out of $1, which is a 0.8 rate. So that is not an 80 rate or an 8 rate, it's a 0.8. So we can use our formula. So our first term is 18 over 1 minus 0.8, which is 1 minus r. And then if you go ahead and solve that, it's 18 over 0.2, which then gives you 90. So it travels 90 inches. And the reason why we know it's inches is because we got it right there. All right, hopefully that makes sense. Think about the pendulum swinging back and forth, or like a clock, like a grandfather clock. That's a good one. If you have a grandfather clock or your grandparents have one, each time it ticks, it moves a little bit less if you were to manually do it.